Hello. This video is for IXL Activity 8.F.2. It's titled Evaluate Exponents. Its three-character code is Echo Yankee Romeo EYR. And here we have to evaluate exponential expressions. Exponential expression is a base with an exponent. Together we would call that a power. So we have to evaluate it, and as we know, evaluate means to actually generate a value, like solve it. It's asking us to pretty much give me an answer for it. That's what they're saying by evaluate. So we should come up with an answer here. So let's go ahead and start off here. We know that 3 squared is equal to 3 times 3, and 3 times 3 is 9. So the first one, not too rough, right? The next one, 4 to the third. So still easy enough. I think I'll be okay without a calculator. Later on, we'll see where calculator is going to come in pretty handy on this. So the 4 times 4 portion, I'm going to first multiply the two 4s to get 16. Now I still need to multiply that times this. I'm going to bring down this, times 4 here. And I still need to do that there. Well, I might need to use the algorithm and maybe do 16 times 4, right? And I can do 6 times 4, or 4 times 6 is 24, carry the 2, 4 times 1 is 1, plus 2 is 6, and I'd see that that's 64. Another way I could do that is if I'm thinking of 16 times 4. Well, let's think of 16 as 10 plus 6, and then multiply 10 by 4 and 6 by 4. That'd be a little bit easier. Then we'll add the products together. It'd be a little bit easier than multiplying 4 times 16. So the 10 times 4, and I'll put it above here, is 40, and 10 times 6 is 24. And so I need to add those together. The reason I'm adding them together is, well, 16 is the same as 10 plus 6. So if I'm doing 4 times 10 to 40, 4 times 6 is 24, then I want to add those together and get 64. If you scratch this out on paper, eventually you get good enough that you can kind of do it in your head. But that's I'm showing my work, you might say, and sharing with you my mental thoughts on how I get there. But the answer here would be 64. So yeah, I could still do that one without a calculator. We're going to find later on where I might want to use a calculator on some. So on the next one here, I have 8 times 3. 8 times 8 times 8, that's 8 to the third power. And 8 times 8 is 64. And I still need to multiply this by 8 as well. Well, I could do, I could break that apart. I could do some mental math there and do 8 times 60 and 8 times 4 and add those together. Or I could just go ahead and use the standard algorithm of 64 times 8. And 8 times 8, or 8 times 4 is 32. Carry the 3. 8 times 6 is 48, plus 3 is 51. So I get 512. Now, notice that here 8 is the base and 3 is the exponent. What if 3 is the base and 8 is the exponent? So that is 3 times 3 times 3 times 3. There, I'm halfway there. Times 3 times 3 times 3 times 3. There, 8 of them. Wow. Now, I could do 3 times 3 is 9, and do this one here, 9, and these two here are 9, and these two here make 9, and then I could do 9 times 9 is 81, and 9 times 9 is 81, and then have 81 times 81. For that one, I might want to use the lattice method. So the lattice method, I'll put 81 and 81. And the reason we call this a lattice method is whenever you get done creating this thing, it looks like a lattice fence. That's where it gets its name at. So the idea is we're going to put one of the numbers across the top, one of the numbers down the side, and we're going to give each of the top numbers its own column, and each of the side numbers its own row. So we have columns and rows. And then we're going to break this bad boy down here like this, draw diagonals through each square, and now we're all set up. So we're going to take right here in this part right here, here and here, At those 2 points right there, we're going to put the answer to 8 times 8. Whatever number is in this column, match up whatever numbers in that or the row where those two intersect. And the tens place is going to go in the upper left and the ones place in the lower right. So 8 times 8 is 64. 6 in the tens place, 4 in the ones. 8 times, let's go 1 times 8 in this box right here. 1 times 8 is 8, so 0 tens and 8 ones. Here we have 8 times 1, no tens, and an 8, that equals 8. And 1 times 1 is 1. No tens, 1, 1. Now we start adding diagonally through here. So we're adding down through, let me change my color here so you kind of see a difference. We're going to add this way, that way, right through there. We're going to add these rows going that way and put the answers out along the side here. Okay, so let me do some undos here to get rid of those. Outstanding. And go back to red. Good deal. So 1, just here. 8 plus 0 plus 8 is 16. And we're going to put the 6 there. And just like adding stacked numbers, we're going to carry that 1 up to that next column here. So 1 plus 4 is 5. And then we got the 6 there. So now let's take our numbers reading around this way. We're going to just write them out going across there for 6, 5, 6, 1. Wow. 6,561. There is an easier way. And I do want to show you this here, but I know most people are going to use a calculator for this. So let's go ahead and take a look at that. Let me grab my calculator. So here I have my graphing calculator here, and it's the computer version of it. So I'm going to go ahead and do this 3 to the 8th power. So I'm going to press 3. You'll see it come up here on my screen. Also, I have a key press history here. Let me clear that out. Actually, let's clear that. Yes, I want to clear. Oh, no. The answer is yes, clear it. Let me clear the whole thing. Clear that. Let's clear this. Yeah, there we go. So anytime I'm using this, if you see it and you want to try to follow along what I'm pressing, notice I pressed this 3 in the key press history. It shows the key that I pressed. All right, so 3 to the 8th power. Well, 3, and this button right here above the operation signs is called a caret. And I'm going to press that. And notice that I get a box here for my exponent. So my exponent's 8. So I have 3 to the 8th. And now I'm just going to push this enter button down here all the way down the bottom right-hand corner. That's the same as an equals button. Press that. 6561, 6561. So apparently I did my math right. God, I hope so, right? All right, so let's go ahead and we'll minimize that. And 15 to the 3rd power. So this here's another one of those where you start trying to figure out, wow, that's probably going to be easier to do with the calculator. It's 15 times 15 times 15. And 15 squared, I believe, if I know from memory, I believe that is it 225, right? 12 squared is 144. 13 squared is 169, I believe. Numbers getting up there. Let me go ahead and grab my calculator here. Pull that up, and we'll go ahead and move that over to the side. And let's go ahead and do this 15 cubed, right? So press 1, 5, the caret sign. So I got that in there. Press that. I'm thinking this is like 225. Do I remember that? Wow, I was way off. 3,000. Oh, I was thinking 15 squared, just the 15 squared part. And then if I take that 220, we can find that out. Let's divide that by 15. Is it? Yep, 225. So 15 times 15 is 225. Then I multiply that to it. It was 3375. So if I do 15, 3375 before I forget. If I do 15 times 15, I get 225. And then if I multiply it by the other 15, then I'm going to get that 3,375. So 4 to the 6th power, that is not 4 times 6. This is not 24. Okay, so a lot of people make that mistake. It is 4 times itself 6 times. Was there 5 of them? And I could do 16, 16, and then 16, and that'd be pretty tough there. Now we know that this number should be more than 3,375 because this was 15. That was just 15 cubed. Well, that's going to be a big number. So let's go ahead and check that out, see what that is. Pulling up the calculator there, and we'll slide that calculator over here so we can see it. And we want 4 to the 6th. So 4 to the 6th power. And that's going to give us 4,096. So 4,096 is our solution there. Looking at our next one, now we get into, oh, well, these don't look too difficult, right? Oh, those got kind of crazy right there, right? So right now, these earlier questions were asking, do you know how to evaluate? You could work it by hand, like the earlier ones we did over here, but obviously these other ones that are going to come to big numbers, most likely most people would do it with a calculator. And so let's look at the other ones here, though. So 2 to the 1st power. Well, that's just 2, right? Times itself once. So all we just have is 2 on that one there. This next question here, 1 to the 7th. Well, we could do 1 times 1 times 1 times 1. There's 4 of them, 5 of them, 6 of them, 7 of them, right? 4 and 3, 7. What's all that equal? Well, we know that 1 times 1 is 1 times 1 is 1 times 1 is 1. Get the idea? So 1 to any power is still going to equal 1. That's the key concept of that question there. Any 1 to any power is still going to equal 1. What is 8 raised to the power of 5? Well, what they want to know is here is, do you know how to take the words and convert it over to 8 to the 5th power? Now, this is definitely something that I would use the calculator for. So we'll go ahead and pull that up and slide that over there. And 8 to the 5th. So 8 to the 5th is going to give us 32,768. 32,768. 32,768. Big number, right? And then what is 7 raised to the 4th? They want to know, do you realize this is the base and this is the exponent? So 7 to the 4th. And grab my calculator again. And we're going to do 7 to the 4th. So 7 to the power of 4. That would actually be 49, same as 49 times 49. That's going to be 2,401. So 2,401. And what I was saying a second ago about it, 49 times 49, I know it's going to be 7 times 7 times 7 times 7. Well, these two 7s have factors. 7 times 7 is 49. And then I have these two 7s, that's 49 also. And then I could use Lattice Method, or I could use the traditional algorithm of 49 times 49. And I could go that route and solve it that way as well. If you do it, if you don't have a calculator and you're doing it by hand, that Lattice Method that we used right here works real well. Or of course the traditional algorithm. Okay, so let's go ahead and look at the next one. Here we have 10 to the 0 power. Now, we haven't talked about anything to the 0 power yet. We talked about the 1st power, 2nd power, and there's also negative exponents. And we'll get into that some other day. But right now we're going to talk about some number to the power of 0. Instead of using 10, let's use another number. Let's see if we can find a pattern. Let's do 2. 2 to the 0 power. And let's do 2 to the 1st, and 2 to the 2nd, and 2 to the 3rd, and 2 to the 4th. Let's see if we can find something. Well, let's say we don't know what 2 to the 0 power is. We're just trying to find something out, right? But 2 to the 1st, right, is 2. And 2 to the 2nd is 4. And 2 to the 3rd, well, 4 times 2 is going to be 8. And 2 to the 4th is going to be 16. So what's the pattern here? As we go from 16 to 8, you might say, oh, we subtracted 8. Well, to get to 4, subtracting 8 doesn't work, right? So minus 8 doesn't work. So what works for the pattern all the way? Well, what do we take 16 and divide it by 2? Divided by 2. 8 divided by 2. Oh, is 4. What about 4 divided by 2? It equals 2. So let's go here and do 2 divided by 2, and what do we get? 1. Well, it worked for 2, but maybe it's just 2's. Let's look at 3. 3, so 2 to the 0 power is 1. Let's look at 3 to the 0 power. 3 to the first, 3 to the second, 3 to the third, and 3 to the fourth. So, assuming I don't know what 3 to the 0 power is, but I do know 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, and 3 to the fourth is 81. Not 88, Mr. T, 81. So, how do I get from 81 to 27? Well, I could be subtracting, I don't know, it's almost 50 something. No, that's not it, because it doesn't work to get to 9. So I must be dividing. So I'm dividing by what? 3. 27 divided by 3, 9. 9 divided by 3 is 3. 3 divided by 3 is 1. And you'll find no matter what base you use, the pattern will always come back to whatever that base is to the power of 0 always equals 1. So what is 3 to the power of 0? Well, we saw that right down here, right here, is that it is indeed 1. So any number to the power of 0 equals 1. Then we get into this cool deal where if we have a multiple of 10, that is, say 10, 100, 1,000, 10,000, 100,000, just a 1 with zeros behind it, right? And then raise it to a power, what happens there? So let's check this out. 10 times 10 times 10. And that's going to equal, well, 10 times 10 is 100, and 10 times and 100 times 10, well, we just throw another 0 on the back right there. We kind of figured that out, that the 1 times 1 part always equals 1, and we end up with however many zeros there are. How many zeros are here? 1. What's 1 times 3? Take the number of zeros, multiply it times the exponent. It's 3. How many zeros do we have in the answer? 3. So it's 1 with however many zeros there are. 1 times 3, we get that many zeros. Kind of a shortcut for it. Works out pretty cool. What about this one here? 10 to the 5th power. Well, I'll show you what happens on a calculator. Let's look at the calculator there. And what happens on a calculator whenever we do 100 to the 5th. So I'll go ahead and clear this out. Clear that out. 100 raised to the 5th. So if you're using a calculator and you're trying to do your homework and you would come up with this, what in the world is 1E10? You can't type that into IXL and get a correct answer. If you type in 1, the letter E, 10, it's not going to work out for you. It's going to tell you wrong. Doesn't work. So that's not going to do any good. And this does mean something to me. It might mean something to you too, but right now is not the time to go there. We'll talk about that some other time. So let's figure this out. Well, let me see. If I take the shortcut, there's 2 zeros, right? And 2 times 5 equals 10. So could it possibly be a 1 with 10 zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to have to test myself on place value here. Let's see, thousands, millions, is that billions? Is that 10 billion, I believe, right? So if we did this and wrote this out, 10 times, or 100 times 100 times 100, it almost looks like divided by 2. Times 100 times 100, is that 5 of them? So 100 times 100 is 1 and the 4 zeros. 1, 2, 3, 4. So that's these two to there. Now I multiply it times this and I get the 4 zeros and then add 2 more zeros. So that took me there. Now multiply times this 100. That's those 6 zeros. 1, 2, 3, 4, 5, 6. And now I need 2 more zeros. And so that got me through here. Now I'm going to multiply times this 100. And my answer is going to come up here. So I now have 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros, and I have to add these 2 zeros now, and sure enough, I end up with the same tick, tick there, 10, I think it's billion, thousands, millions, billions. Yep, 10 billion. I've never seen a paycheck that big, so that's why I forget those numbers sometimes, right? And this is the last one here, so we could use that shortcut here. I have 3 zeros and an exponent of 2. 3 times 2 equals 6. So I need a 1 with 6 zeros. 1, 2, 3, 4, 5, 6. So that's going to be 1 million. 1,000 squared is 1 million. And then what is 1,000 to the 4th power? Wow, 3 zeros. So 3 times 4 equals 12, so I need a 1 with 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I think this one's going to test me even further. Trillion, I believe. Thousands, millions, billions, trillion. 1,000 to the 4th power, 1 trillion. All right. So those are all of my examples for IXL. Activity 8.F.2, evaluate exponents. Remember on your calculator, that little caret button help you figure that out on how to raise it to the power. So good luck on your activity.